A faint streak of light tears through the cosmos at 150,000 miles per hour, a cosmic wanderer from beyond our solar system. On July 1, 2025, NASA's Atlas survey in Chile recognizes it. A fleeting dot in the sky moving too fast to straight to belong to the family of our sun. They give it a name, 3I. Music confirmed, a rare visitor from the depths of another star system. However, something extraordinary happens. Its path bends in ways that defy the laws of orbital mechanics. And precisely at the moment of NASA's live feed, this cosmic curveball cuts to black. No warning, no sound, no explanation. Comets were once considered omens, chaotic streaks of fire. Today, millions are left wondering, was this a glitch of nature or something science can't yet name? Let's get started. The story of 3I ATL, a celestial mystery that has the world's attention and challenges our understanding of the universe. Subscribe, like, and join me as we collaborate to solve this mystery. At 4:12 UTC on July 1, 2025, the Atlas telescope in Cerro Pachón, Chile, flags a faint, fast-moving object just a handful of pixels against the starry backdrop. Led by Dr. Elena Sands, the Atlas team pulls the raw data and runs it against the Minor Planet Center database. The figures don't add up. This thing is clocking 67 kilometers per second, far too fast to be bound by the gravity of the sun. Its trajectory is hyperbolic and straight, a ticket through the universe, starting in the direction of the constellation Lyra. Within hours, follow-up observations from Atlas's sister site in the Canary Islands and the Zwicky Transient Facility in California confirm it. This is no ordinary comet. It's an interstellar interloper, only the third of its kind ever discovered. The first was Oumuamua in 2017, a strange cigar-shaped rock that sparked debates about its origins. The second, in 2019, was Borisov, a classic comet but laced with exotic chemistry. Now, 3I, bigger, brighter, and already stirring up questions, takes center stage. What makes 3I so special? For one, its size. Early photometry suggests the nucleus is about 10 kilometers across, massive compared to most comets. As it gets closer to the sun, its icy surface warms, triggering outgassing. Frozen gases like carbon dioxide and water vaporize, forming a glowing coma, the hazy cloud that makes comets so iconic. By mid-July, the Hubble Space Telescope and the James Webb Space Telescope are trained on it, capturing spectra and images that show a haze of pale blue blooming around the nucleus. The Minor Planet Center issues daily updates, narrowing its orbit down to fractions of an arcsecond. The math is clear. It will swing closest to the Sun or perihelion at 1.44 astronomical units just inside Mars's orbit on October 30th, 2025. Its closest approach to Earth, a safe 1.8 astronomical units or about 270 million kilometers. A front row seat, but no danger. A once-in-a-generation event. For scientists, this is a gold mine, a chance to study material from another star system, unaltered since the beginning of time. But here's where the story takes a turn. Comets are unpredictable by nature. As they heat up, jets of gas and dust erupt from their surfaces, acting like tiny thrusters that nudge their paths. Astronomers account for this with non-gravitational parameters, small tweaks in their models labeled A1, A2, and A3, measuring radial, sideways, and out-of-plane forces. Typically, these forces are minuscule, on the order of 10 units per day squared. However, 3I ATL is different. Its deviations are staggering, requiring forces 10 times stronger to explain its jittery, wobbly path. JPLS Horizon System, the industry standard for orbital predictions, churns through the data. Every planet's gravity, solar radiation pressure, even relativistic effects are factored in. Yet the residuals, the gaps between predicted and observed positions, refuse to shrink. The comet's path doesn't just drift, it jumps, almost as though it were firing thrusters in sharp, unpredictable bursts. Monte Carlo simulations, thousands of virtual comets, can't replicate this pattern without invoking bizarre, rotating jet activity. Something's not adding up. For centuries, comets have unsettled humanity. In ancient China, broom stars swept across the sky, dispersing like cosmic brushes. The Han Dynasty's bamboo annals logged over 100 such events, each tied to famine, war, or the death of an emperor. In Babylon, cuneiform tablets called them movers of change, their paths a divine script. In 1066, a comet blazed over England, immortalized in the Bayeux Tapestry as an omen before the Norman conquest. Even as science advanced, comets kept their mystique. In 1680, a brilliant comet caused widespread panic across Europe, its path unreadable to the naked eye. Newton and Kepler cracked the code of orbital mechanics, and comets finally became predictable. Or so we thought. Their outgassing can still result in surprises nuclei that split, or a sudden brightening. But 3AT's deviations push the boundaries of what we've seen before, echoing that ancient unease about wandering stars. It's a reminder that the universe still holds secrets even in our age of precision. Now, let's talk about that blackout. On July 18, 2025, at 3 hours 17 minutes and 12 seconds UTC, NASA's live feed tracking 3I Atlas cuts off. No warning, no fade, just a razor-sharp drop to black. The last frame, archived by independent mirrors and time-stamped by NIST, shows a geometric streak of light, then nothing. File hashes from NASA's servers, the Wayback Machine, and third-party platforms match perfectly. No tampering. No local glitch. The Deep Space Network's logs cross-checked across stations in Madrid, Goldstone, and Canberra show no scheduled maintenance, no antenna swap, no solar interference. Other missions' data flow uninterrupted. Only the Atlas feed vanishes. Amateur astronomers, from Unistellar's Citizen Network to backyard telescopes, report the same instant loss. No anomalies in their synchronized logs, no sensor errors, no network hiccups. YouTube re-uploads and social media archives preserve the exact cutoff frame, perfect across platforms. This isn't a glitch, it's a global, unexplained blackout? What could cause such a precise and documented silence? Share your comments, your thoughts are welcome. The timing couldn't be more suspicious. 3-1. ATLAS's path takes its most dramatic shift just before the feed cuts. The spiking of JPLS model residuals demonstrates a deviation that defies standard outgassing. Most comets drift gradually, their jets peaking near perihelion. But 3AT's greatest increase occurs weeks earlier, as if a massive jet fired, then stopped, then fired again. Analysts try every trick in the book: variable thrust vectors, impulsive velocity kicks, even exotic ice compositions. Nothing fits cleanly. The comet's 10 kilometers nucleus should be too massive for such wild swings unless it's porous or riddled with unseen vents. Spectra show carbon dioxide and water, but nothing extraterrestrial enough to explain the behavior. Independent researchers on preprint servers float wild ideas. Could it carry volatile compounds from its home system, vaporizing at odd temperatures? Or is it simply our models failing to keep up? The data tease but don't answer. The blackout only deepens the mystery, forcing us to wonder what the next frame might have displayed. Let's deal with a common misconception. Comets don't just change course at random. Their paths are governed by gravity and outgassing, predictable with enough data. But 3I Atlas stretches those predictions to the breaking point. Some online forums buzz with wild theories, alien propulsion, secret government cover-ups, but science demands evidence. The residuals, while extreme, still fall within the outermost edge of known comet behavior. No catalog flags it as an outlier, and no photometry shows a nucleus splitting or a violent outburst. However, the nervous step-like drift and the blackout's perfect timing fuel speculation. NASA's silence doesn't help. Public affairs logs offer no explanation, and FOIA requests pile up unanswered. Citizen science networks from AAVSO to Unistellar step in, sharing raw FITS files and open audit logs. Their data confirm the blackout and the deviation, but the cause remains elusive. This openness is science at its best: collaboration, transparency, relentless pursuit. Want to join the hunt? Check out the links in the description to explore the data yourself. The human side of this story is just as compelling. Imagine being Dr. Elena Sands, leading the Atlas team as they track this cosmic anomaly. Your instruments capture a once-in-a-lifetime object, but your models fail with each new data point. The world's watching, and history's taking notes. Or picture the amateur astronomers hunched over backyard telescopes, contributing frames to a global puzzle. Their work, alongside NASA's, builds a picture no single observatory could. This is a tale stretching from ancient stargazers' fascination to modern coders, all chasing the same question: what's out there? 3i. ATLAS reminds us that science isn't just about answers, it's about the courage to face the unidentified. The blackout, the residuals, the jittery path, they're not just data points. They're a call to keep looking, to keep questioning, to keep exploring. So, where does this leave us? 3.1. Atlas is still out there, streaking toward perihelion. Its path, tracked by telescopes worldwide, shows deviations that, while extreme, haven't violated the laws of physics, only stretched them. The blackout remains unexplained, an omission from the record that invites both wonder and skepticism. As of September 22, 2025, NASA's logs are silent, but the global astronomy community is anything but. Independent data from server logs to FITS files keeps the discussion alive. This interstellar visitor, born in a distant star system, carries clues to the universe's past and the challenges of its present. Will the next observation solve the mystery or deepen it? One thing's certain: the cosmos doesn't owe us answers, but it dares us to ask. Like, subscribe, and share your thoughts below. Let's keep exploring the unknown.